So this is a question that came up in the Alibra forums, but to my knowledge it's a challenge in any CAD system, and that question is, how do you assemble two cones at the point that they would naturally meet? So here we've got a 93-degree cone. Its minor diameter is 4 millimeters and its major diameter is 7. This is just an example I've drawn here. And here we have a 90-degree cone. The minor diameter is 3 and the major diameter is 6. So how can I assemble them so that they sit at the exact point that they would if they were put together in real life, right? So the way we do that is we create a reference geometry in the correct location and then use that to assemble. So first we edit this part, which I have cut in half so you can see what's going on a bit better. We create a point in the middle of this diameter, hit apply, close, and we're done. That's all we need to do here. Okay. Then we need to edit the part with the cone. Okay. So we go into the sketch this time, and we need to find the line that created that cone, which is this, right? And what we're going to do is we're going to draw a reference line. Let's draw it arbitrarily, okay? One point touching the line that creates the cone, and we will define that as. So first of all, this needs to be perpendicular to the axis of rotation. So we can either use the perpendicular constraint, or we could have used the horizontal constraint, or just drawn it horizontal from the beginning, right? Because this is vertical, so if this is horizontal, it is by definition vertical to that one. Perpendicular to that one. The next thing is the midpoint of this line needs to be on the axis of rotation. So here I'm going to use the trick I show in another one of my videos. I'm going to use the midpoint constraint with 3 points. So I'm clicking 1, 2 points. Now I have defined this line segment, and then I'll say that this third point is always going to be on the perpendicular bisector of the line segment I defined with the first two. But because this point is part of the axis of rotation, the axis of rotation becomes the perpendicular bisector, and you can clearly see what we have achieved here. This reference line follows the cone. And finally, I want to give a dimension to this reference line of the diameter where the intersection will happen. So that is 4 millimeters. Okay, that is the minor diameter of the 93-degree cone, and that is where the two cones will touch. So after I have done all of that, I'm going to use this insert axis from sketch tool. I'm going to use this line to drive a sketch, right? To drive an axis, sorry, to drive an axis. Cool. I exit out of the sketch, I generate to last, and then I'm going to create a plane. I'm going to use the axis I just defined, and any plane or face that is normal to the axis of rotation. I can choose this plane, I can choose the ZX plane, or whatever. At this point, the ZX plane will do. Hit apply, close. Now I have the reference geometry I need, so I'll go back up to the top level assembly. In order to use reference geometry from within the parts, I need to do this. Right click on a part and show reference geometry. I can also do that by hitting Alt 0. So I'll just left click here and hit Alt 0. There we go. Okay, and I also need to show my points. So constraint. First of all, I'm going to make no. So first of all, I need to make this and this coaxial. And then the next thing I'll do is I'll make this point I just created, I'll mate it to the plane I just created. Okay, hit apply, and look at this. We are perfectly on the location that we need to be. That is the precise location that the two cones touch. Okay, so that's how you would do that. You can clearly see that this pin can still rotate. If you don't want it to rotate, you just deal with that as well. And we can stop showing our reference geometries. I need to see the points anymore. And that's it. That's it. We have perfectly located these two cones. Okay, you can see the difference in angle as well. So that's how you would do that. If you want to, go completely overkill, you could drive the minor diameter of this cone from a global parameters file, and then dimension that line using that same global parameters value. That way, when you change that cone, the line would change, the axis would change, the plane would shift, and this pin would fall into the correct location automatically. That's by using a global parameters file. Again, it's a bit of an overkill. So if you like this, hit like. If you didn't like, hit dislike. And if you want more tips and tricks like this on Alibre and other CAD systems, subscribe to our channel. And thank you for watching.